Hello everyone. Today I'm going to discuss about Wheatstone's network. For the same, here is the circuit diagram. Okay, so this is the basic circuit diagram for the Wheatstone network, which consists of cell here or power supply, which has positive terminal and negative terminal, and this is the key, and which provides the current I, that is called as main current, and this is the point A, this is B, C, and D. Okay, these are the four resistances which are connected in the cyclic order. Let me call them as a P, Q, R, S. P, Q, R, S are the four resistances. P, Q, R, S. The resistances, correct? Then here I is the main current. And K is the key. Okay, and here is the galvanometer G, which is connected between B and D. Galvanometer. All right. Okay, and now this I enters at point A will split up into branch currents. That is taken as I1 and another current which is flowing through here, that is taken as I2. Okay, the I1 which is passing through the resistance P then will come to the point B. Again, it will be split into sub branch current, that is one current which is passing through the galvanometer, that is taken as IG. IG is the current through galvanometer, IG. Current through G. G stands for galvanometer. And another current which is passing through resistance Q is the till this point the current which is coming is I, okay, I, and which will be splitted into IG here, and rest of the current will be moving here. Then I will take it as I1 minus IG. Up to point B, the current I1 is entering. So that will be splitted into two sub branch current. One is IG and another one is I1 minus IG. Okay, and I2 is the another current which is passing through the resistance R, and IG is the current which is passing through the galvanometer, and the same current which will come and meet at the point D, where I2 and IG will meet at point D, and after that they will pass through this S, resistance S, that will be taken as I2 plus IG. So what I can write here, I1, I2 are taken as branch current. Okay, so now we have to apply Kirchhoff's voltage law for the cyclic quadrilateral A, B, C, D, A. Okay, so here A and B, C, D are the four nodes or the points. Okay, where P, Q, R, S are the four resistances which are connected here. G is the galvanometer. Now let us start mathematically. Okay, so here let us apply KVL to the loop ABDA. Okay, let me take this loop as first loop. A, B, D, A is the first loop. For that, we have to apply KVL. So now what I will do, we will start from the point A. When we are moving in the direction of the current, then we have take IR product as negative. So now we are starting from the point A. Along with the current, we are moving in this direction of the current. When we are moving in the direction of the current, we have to take IR product as potential as negative. So I1P is taken as negative minus I1P. Again, we'll come to the point B, then we'll have to go to D via G, that we are moving via, along with the current of galvanometer, that is IG. So now I'll write it here, minus IGG, because when we are moving along the direction of the current, we have to take it as minus. And after coming to the point D, we have to go in the direction opposite to the direction of the flow of the current here. So then we have to take it as positive. That I will take it as I2R equals 0. Let me call it as the equation number 1. Here, let me explain again. For the first loop A, B, D, A, we have to apply KVL, Kirchhoff's second law or voltage rule. So here what I have done here, when we are moving along the direction of the current, we have to take it as negative. And when we are moving along the opposite to the direction of the current, the IR product must be positive. Okay, now we'll apply KVL to the second loop. Here is the second loop, BCDB. BCDB is the second loop. The second loop is BCDB. Okay, where we have to apply. Now again, we are starting from the point B to C. We are moving along the current I1 minus IG through the resistance Q. So how we can write it here? Minus I1 minus IG, because we are moving along the direction of the current, into Q, plus here again we are going from C to D, which is opposite to the direction of I2 plus IG. So when it comes to opposite, we have to take it as plus I2 plus IG into S. Again from D to B we have to go, that is again opposite to the direction of the current. So I'll take it as plus IGG equals 0. Let me call it as the equation number 2. And we should understand one important point here. The network is said to be balanced when current through the galvanometer G is 0. Okay, so where I can write it as IG equals 0, the current through the galvanometer is 0, then we can call it as the equation number 3. So here we are trying to say that the circuit is said to be balanced when the current through the galvanometer is 0. Then what I can do with the first equation is, let us write the first equation again, I1P minus IgG plus I2R equals 0. I'm just rewriting the first equation again. So when the galvanometer is said to be, having the zero current, I mean the circuit is said to be balanced, then Ig equals 0, then I'll consider as a 0. Then we left out with minus I1P plus I2R equals 0. By simplifying this, we will get I1P equals I2R. Call it as the equation number 4, where minus and minus will get cancelled each other. Now we have to consider the second equation. Second equation is here. Okay. Minus I1 Ig into Q plus I2 plus Ig into S plus IgG equals 0. We have to remove the bracket here. So minus I1 into Q, minus into minus plus IgG, Ig into Q plus into plus plus I2 into S plus into plus plus again Ig into S plus IgG equals 0. We already know that the circuit is said to be balanced. Then we can consider this Ig is 0. Then we can directly make into 0 here. So we left out with minus I1Q plus I2S equals 0. The further simplifying this, I can write it as I1Q equals I2S. Call it as a fifth equation. Now, finally, what we can do here is, okay, this is the fourth equation. Okay, and this is the fifth equation. Okay, now what I will do here, we have to divide equation 4 by equation 5. So equation 4 is what here? I1P equals let me rewrite it. I1P divided by I1Q equals I2R divided by I2S. So I1 will get cancelled, I2 will get cancelled. So finally we left out with P by Q equals R by S. Okay, so this equation is called as balanced condition for a Wheatstone's network. Okay, by knowing any two values or any three values, we can find the another resistance value here. So this is one of the important 5 marks questions. Hope it is clear. So kindly share with your friends and keep following and subscribe the channel for the for more videos. Thank you very much.